I'm going to use the collet chuck to do the machining. A couple of reasons really. It's easier for me video and I haven't got the chuck in the way, and I've got some more machining to do on the milling machine. There's a couple of ream holes to go in, so I'll need the collet block to do that. So we need 2 inches of thread. So make sure I've got 2 inches poking out of there. If I could find my steel ruler, of course. There we go. Right, 2.5, that's plenty. Nice and accurate this as well. I like using the collet chuck. So we'll face the end, we'll turn it down to 1/2 inch for a length of 2 inches. We'll put a little recess in there for the screw cutting tool to drop into, which would be the core size of the thread. I'm going to do this in metric. It's a metric lathe that's just easier. So I'll measure 1/2 inch, then I'll get a conversion onto that. Right, so if I simply open this to 1/2 inch, which is there, change the metric 12.7, click original. That's now set at 0, so now I get a direct reading of how much I need to take off that piece of bar. Put that on there, and it says I need to take 6.32 to get that down to 1/2 inch. Simple as that. I'll start the lathe up, face it, turn it down to 1/2 inch. Right, you can hear them chain views clattering about, nothing to worry about. Put a 2mm cut on. That'll take 4mm off it. Quite a rough cut just to get down to size, just to get some material off it, that's all. The chips are breaking really nicely. The lathe's a lot quieter when it's got its metric transfer gears in. Sounds terrible, it's not doing any harm really. Right, so that's 2 inches. Measure it again. You need 1.8. We'll take a 0.6 cut and then leave a little bit to take off at a nice high speed. As if you think the change wheels are noisy there, you want to hear them on a higher speed. Putting a much better finish on the lighter cut. See, it's just bright steel, mild steel bar, it's nothing special. Chips on breaking very well, coming off in horrible scabby strands. Not what we want, but you know what I mean. Right, so now we want 0.6 of it. Just feed this one in by hand now to get a decent finish on it. Right, so that is 2 thou under 1/2 inch, which is certainly acceptable. I'm going to put a little chamfer on there, a little lead, just to help the screw cutting tool start, and then I say we'll put a recess in there for the screw cutting tool to cut into, and that'll be the core depth of the thread. So once again, I'll measure the core depth of the thread. I think it's 10.5 normally, 10.25. So if we click original, our origin puts it back to 0. And if we take a simpler measurement off here, it's saying that I need to take 1.6 see I need to take 2.48, 2.5 mil off there, which is simple enough to do. You just touch the parting tool off, 0 the access on the DRO. We need to go in, forgot already, 2.5, that's 1.5, 1.25, yeah. Right, I'll put a radius on there once we get the thread cut. You don't want to have nasty sharp edges. I think I'll put a tailstock steady in just to stop it flexing, because it is a weak point there. It takes nothing to put a centre in. In fact, quite often on jobs I make for people, I put a centre in because they quite often come back to me and say, "John, it's too big." But with a centre in, I can put it in, set it up, and accurately and quickly. Right, so we'll centre drill it. So I can get the glazed carriage a lot closer because I haven't got the bulk of the chuck in the way. The Martian snot on there. The revolving centre goes in there. Make sure there's no crap in the hole. Just a little bit of weight, doesn't need a great lot, just enough to hold it. Just like that. That's the screw cutting tool I'm going to use. It's a 12 TPI foam tool. Make sure it's on centre height. One easy way is to put a steel rule in like that, and the steel rule is straight up and down. If it was across like all of that way, it wouldn't be on centre height, but it is absolutely spot on, because I do use this tool holder all the time. Right, the next thing to do is to make sure that the tool is at 90 degrees to the job. That's quite simply done by bringing it against the collar chuck face like that, and you can see that there it is absolutely 90 degrees to the job. So it's square to the job and it's on centre height. Back in the day when we were using high speed steel for screw cutting, not these inserts, you used to angle the compound slide and put the tool in so it was only cutting on the front edge of the tool. That's the old fashioned way to do it. You still do it that way on bigger threads, but on a small thread like this, these tips are designed to go in and do it all in one cut. Nothing to stop you angling the compound slide, but with these tips you don't need to. So what we need to do now is, now we need to set up the gearbox to cut a 12 TPI, and then we can get on and get some threads cut. Right, so this is the screw cutting gearbox on the lathe, and that's the magic lever, the third lever that not all Harrisons have got. So to cut 12 TPI, which is that one there, it's telling me that the two left hand levers need to be across to the left like that, and the right hand lever needs to be where it is. So it's 12 TPI, both end to the left, that one to the right. Now it tells us where to put this tumbler one. Fourth hole in from the left, 1, 2, 3, which is that one. I have to turn it so it doesn't want to go in the mesh, but it will, that's it. Right, so make sure it's right. Left, left, right, 4. That's hopefully will cut 12 TPI. We need to engage the lead screw. It's on a dog clutch like that, that's it engaged. I'm going to slow it down a little bit. I'm not in a hurry, and I can get some better, bastard, and get some better camera shots with the lathe run a little bit slower. Right, first thing to do is touch the tool off That's it there. I'm set to 0 on the lathe cross slide. I'll also set to 0 on my DRO. Right, so I'm going to put some cut on. I'm going to put 0.1 of a mil on, just a scratch cut. Now once I engage the half nuts on the lead screw, it starts screw cutting. I can't disengage them, I've got to leave it engaged. Just stop the lathe, wind it out and reverse it. It's all ready now to start screw cutting. I've got my hand on the clutch ready to stop it. It really starts to go fast towards the end. Right, so disengage there. I'll get the thread gauge and we'll have a quick measure just to make sure we're hitting the right numbers, which it certainly appears to be doing so. So next we'll simply reverse the lathe back. Cross slide back to 0. Right, I've got a little bit of an issue. The lathe tool is touching that centre, so I'll put a different centre in. It's not the end of the world. This is the one I should have used in the first place. That's my best one. Okay, a bit more clearance there. Right, so wind this back in to 0, which is there, and then we'll give it another, but we'll let it go into the same setting just to make sure. We'll let it do one more pass on the same setting. Like I say, it starts to speed up really quickly when it gets towards the end, a bastard like that. You've got to be on the ball to stop it. It's quite simply out, reverse, back into 0. This time we'll put some cut on. A little bit of lubricant, never goes amiss. Onward we go. We've got to have full concentration. It's not easy to do, it's easy to make a mistake, especially when you're playing with cameras. You can see when the tool comes up to the end, I haven't left myself much room to stop in. The thread's getting fairly well near to being finished now. Another spring cutting off, we tried it on. Having the clutch on the lathe makes a massive difference. The reverse gear really does help as well. So we'll do a spring cut on exactly the same setting. That's no extra feed on, that's just taking the spring out of the job. This is not particularly good material, the machine. It's a little bit what I call chewy. But it's what the lad supplied, so it's what I'm going to use. It's starting, but it's still tight. This bed's still got a flat on top. We'll do one more cut. Once again, on exactly the same setting. That's nice. Not piss wobbly, but not too tight. I could have run a die down to finish it off, but I decided to screw cut it. I'm quite happy with that. There's a little bit more machining to do on the shaft, which I can do in the next video. Just going to knock that edge off there. All my tools are still covered in that horrible tough nail stuff from the gear cutting. That's not bad. It's not wonderful, but it's certainly acceptable. Had I used stainless steel or a bit of an EN8, that would have been absolutely spot on. I'm sure you'd be happy with that. Once again, we've got a pretty nut and a pretty thread. No piss wobbles, but not tight, just nice. There's some more bits and pieces of machine to do on the shaft. There's some imperial holes to drill and ream, but basically I'm happy with that. Once again, it's just time to say thanks for watching, thanks for subscribing. Don't forget, if you're pissed off, you think you're depressed, go and see a doctor. Talk to your friends, do not bottle it up, please lads. And lasses, it's important you get the help. The help's there, you just got to ask for it. Anyway, thanks for watching.